Teach Pokemon to understand. 11.2 area of trapezoids and kites. So we've already done the properties of trapezoids and kites, but now we're going to find the area of them. There's a trapezoid. Remember, the definition of a trapezoid was a quadrilateral and it had only one pair of parallel sides. And so in this case, you see those little arrows on the top and the bottom? Those are parallel, and only those are parallel. The other ones are not parallel. That's what makes a trapezoid. To find the area, how much pink to fill in the inside of the trapezoid, the formula is 1/2 times the height times the two bases added together. Now, the question is, what are the bases? The bases are always the two sides that are parallel. Sometimes they're drawn like this, top and bottom. Sometimes they're drawn side by side. But the bases, the key part is that they are always parallel. All right, so here we have a trapezoid. I know I didn't draw in the little arrows, but it's pretty simple. Let's go ahead and find the area of this trapezoid. It's just 1/2 the height. In this case, the height is 7, not 9. Remember, the same with trapezoids as with triangles. The height and the bases always have to make 90 degrees. And so that's why the 7 and the 15 make 90 degrees. So that's why the 7 is the height. And then the two bases, 15 and 4. Use PEMDAS to solve this. Do parentheses first and then multiply. You should get about 66.5 units squared. Area is always units squared. Here's another example. I showed you this example because a lot of people think, oh, the base is 18 because it's on the bottom. No, remember, the bases are always the two sides that are parallel. So those two, the 12 and the 3. There it is. And then the height is, of course, 18 because it's perpendicular to the two bases. Use your calculator, punch everything in. You should get 135 units squared. All right, what about the area of the rhombus and the kite? There's a rhombus. Remember, a rhombus has all four sides, a quadrilateral that has all four sides equal. The kite has two sets of sides that are equal, so the top two and the bottom two are equal. So we have area of a rhombus and a kite. Now, you might think, oh, we already did the area of a rhombus last section. It's the same thing as a parallelogram. That is 100% correct. The area of a rhombus is the same as the area of a parallelogram. It is base times height. But sometimes that doesn't work. And so there's another formula for rhombus. And it's the same one as the kite. Area is equal to 1/2 d1 times d2. What are d1 and d2? Diagonal 1 and diagonal 2. So the distance from here to here, diagonal 1 and diagonal 2. Notice it doesn't matter which one you call diagonal 1 and diagonal 2 because you're just multiplying them together. Same thing with the kite. This is diagonal 1, there's diagonal 2. All right? Let's do some examples. Let's go ahead and find the area of this rhombus. Diagonal 1, it's actually 4, not 2, because it's all the way across. And diagonal 2 is 12, not 6. So make sure you go all the way across. 12 and 4, half of it gives us 24 units squared. Let's do a kite. Here we go. One of the diagonals is 4 again, but the other diagonal is actually unknown right now. I know the side piece right here is a 6, but this piece is actually what we're really looking for, what we need. So how do we do that? So this is a little bit tricky and it requires a little bit of work. And I'll show you right now. This, if you remember the property of a kite, is 90 degrees. This is a right triangle. This piece is 2 because it has to match this piece. That's the property of a kite. So all you got to do is find x using the Pythagorean theorem. There it is. Plug everything in. It turns out that the x is about 5.6569. All right, so once we have that, we can use the whole thing. Remember to add 3 to the whole thing with this whole thing, which is 4. All right, see I added 3 to this to get that 8. And then use your calculator to punch in the answer. Ooh, I forgot to write units squared. That's kind of important. Going backwards, what if I give you a kite and then I give you the area of that kite and then I ask you to find how long the other diagonal is? Well, we know this diagonal is 10. That's the easy one for the kite. But they're asking you to find how long this diagonal is. All right. So you just start with the formula. Area is equal to 1/2 diagonal 1 times diagonal 2. And then fill in everything you know. You know the area. And then you know one of the diagonals. So just fill it in. And then just use your algebra skills to solve. 1/2 of 10 is 5. And then divide the 5 to the other side. And there it is. The other diagonal is about 18.428 inches. All right. One more slide to go. A word problem. My favorite because they actually get to apply all of these in real life situations. But here we have one diagonal of a rhombus is twice as long as the other diagonal. If the area of a rhombus is 169 millimeters squared, what is the lengths of both of the diagonals? All right, so here's a rhombus. We know that this diagonal is twice as long as this diagonal. So if I call this diagonal x, the other diagonal has to be called 2x, twice as long. And then let's fill in our formula. 1/2 x times 2x equals 169 because that's the area. Simplify it a little bit. The 1/2 with the 2 actually cancel each other out. And you're just left with x squared is equal to 169. Square root both sides. You have x equals 13. Well, usually when you square root both sides, remember it's supposed to be plus or minus square root of, plus or minus 13, but since we're dealing with distances, we're only going to use the positive. All right, so that's actually one of the diagonals. You have to find both diagonals. The other one's just twice as long. So there we have it. Diagonal 1 is 13 millimeters and diagonal 2 is 26 millimeters. All right, short lesson today. Go ahead, try the homework.